Okay, time for another one. We got this beam here. I want to draw the shear moment diagram. And first thing we do, we look at the beam, and then we're going to calculate the reaction. You know how to calculate the reaction. Take a moment about point B, you can calculate A. Take a moment about point A, you can calculate B. And AY comes out to 4,500, and BY comes out to 900. Then BX is equal, comes out to 0. There's no lateral force here. So from here, what we're going to do, we're going to go ahead and we cut the beam right just before A. Not at A, just before A. When we cut the beam just before A, we're not going to have the reaction force involved. We're going to replace it with a shear and moment. We have to calculate the shear and moment at that location. So the shear, we know it's going to be at that point, summation FOY is equal 0. Up is positive again. We have 1,200 1/2 times 600 times 6, and that's 1,800. 1,800 minus V is equal 0, so our V comes out to 1,800 pound right here. And of course our reaction is going to be the other way around, just before the reaction force itself. Then let's find the moment. Well, I'm more curious about the moment. Summation moment is equal 0. Going counterclockwise is positive. All we have is really this right here, which is again, it's 1/2 of 600 times 6, and that's going to be multiplied by this distance, which is 2, and that kind of comes out to 30. Plus M is equal 0, so M comes out to 3,600 down. Okay, that's a kip foot and pound foot negative. Okay, we got that. That's good. And I'd like to find out now, going to the other side of the beam. I want to know what the maximum moment on this side is. So we're going to take this beam, and then we're going to go ahead and cut it at a point we don't know, we call X prime. So we're going to cut it at X prime, and we're going to set the shear is equal 0. Of course, what I haven't done right here, when we cut it right here, let's replace it with the shear. It has to be opposite that one, and we have a moment right here. Okay, now we have this, and I'd like to find out if I set the shear equal to 0, what is my X prime distance going to come out? Very easy. Summation FOY is equal 0. Wait a minute. One thing we have to figure out here first is this point right here. How did I go with that number? What is this magnitude here? We talked about this in class. First, find the slope of this line. The slope is, what is it, rise over run, so it's a 600 divided by 12. We know that's the slope. Then and this one right here, the magnitude of this right here will be 600, okay, divided by 12. So it's going up. For every foot, it's going to be multiplied by 4, but we don't know how much going up, so it's going to be 600 divided by 12 times X prime. Now, then, if you want to know what the magnitude of the whole thing is, which is 1/2 of 600 divided by 12 times X prime multiplied by X, and that's what the magnitude of this force is going to come out. So when we have summation FOY is equal 0 here, we're going to set shear is equal 0. Let's just call it V, and V minus, it's going to be that number which we have 1/2 of, well, is X prime, 600 divided by 12 times X prime times another X prime. And that is equal 0. So and we know this is come out to 0. We just said we're going to set that to 0. And if we cannot figure out this equation, X prime is going to come out to 6 feet. So now we know at 6 feet, we're going to have the maximum moment. Let's go ahead and calculate the moment at 6 feet. And we're going to summation moment is equal 0. And we're going to go ahead to be 900 times 6 feet. That'd be 900 times 6 feet minus 300 divided by 12 right here. Magnitude of this force comes out to times 6 would be 36. And then that's going to be times X over 3. If that's a 6 divided by 3 is 2. and minus m is equal 0. So this m maximum gonna come out to 3600. Okay, so now we know that we need that. So we're going to do a shear diagram right here. So what we're going to do is we're going to come back down here from, because this is coming down, and magnitude is the area under here. That this area is going to be 6 times 600 divided by 2. That become 1/2 of a 6 is 1800. So we're going to come down to 1800 like here. And then we're going to go up 4500. And 4500 go up, that should give us 2700. So from there, it's going to come down again. And we know the shear was 0 at 6 feet. So we're going to come down like this. 900 was right here. We knew that. So let's just concave it down this way. It's not a good drawing, but you know what I mean. That's a shear. That's a good looking shear diagram. Now let's find the moment. Okay, moment diagram. We figured calculate something out. We knew at this point was 3600. We don't have to go ahead and calculate the area under the curve. So it's going to be like that, 3600. And then we knew it's going to be, at this point, it was maximum because we set it up to 0 right there. So that's at 3600 right here. And we're going to come out like this, and it's going to come back down to 0. So there's our shear moment diagram. So this is, there we go.